Hello friends, welcome to the session of Inorganic Chemistry. I am Praveen Kumar and I will be taking up a very simple topic, that is ionization enthalpy. Though the topic is very simple, but still most of the times I have seen that students are committing lot of silly mistakes in the NEET examinations. Let us understand what is this ionization enthalpy. Let me first give you the definition of it, right? It is the enthalpy change when an electron is removed from the outermost shell of an isolated gaseous atom. Okay? It is an enthalpy change. When I use this word enthalpy change, I mean to say that some amount of energy is either given or some amount of energy is released. Okay? Please remember this part. So, it is the enthalpy change when an electron, I am talking about only one electron, is removed from the outermost shell. Please remember, we are talking about the outermost shell of an atom. I am not talking about the electrons in the inner shells, outermost shells, of an isolated gaseous atom, of an isolated gaseous atom. Now, first of all, let us understand, why are we talking about isolated gaseous atom? Why isolated gaseous atom? So, let me give you an example. Say one day I was teaching in the class and there is one very naughty boy who is not concentrating. I try to explain the things, but he is still not concentrating. So, what happens is that I get angry, very angry. Now, what I want to do is, I want to throw this boy out of the class. But the moment I pull him from his hand, his friends, there are 4 or 5, normally you have got a lot of friends. Now, this student is also having 4 or 5 friends. So, the moment I start pulling him out, his friends start pulling him back, or maybe they are holding on his pant. Don't worry about the pant is intact. But now, how much energy do I require to remove this person from the class? If we draw a diagram over here, if this is the boy and it is surrounded by his friends, I am trying to pull him out, but he is being pulled back by his friends. Okay? So, suppose if this person is applying energy of A, and this is A1, A2, A3, A4, A5, then the total energy that I require to remove this electron will be A plus A1 plus A2 plus A3 plus A4 plus A5, right. Now, case number 2, this boy is not having any friends, right, and I want to throw him out of the class. Nobody is interested to pull him back. He does not have any friend. Okay, fine. So, now when I pull him out, how much energy I have to apply? Tell me. You will say, sir, only A, right. So, this is the minimum energy that you will require to remove this electron out of the atom. Why we are using the word minimum? See, over here I have already signified outermost shell. So, basically the point is that, see, this is the nucleus and this is the electron. which is at the farthest distance from the nucleus. The electron is at the farthest distance from the nucleus. So, when you are giving it some energy, you require minimum energy to remove this. Okay? So, we will always go by this standard that we have to provide minimum energy and take out this electron out of the atom, and that is how we define ionization, right. Now, as I said, I hope you must have understood. It's very easy concept. Now, let us see what kind of questions are asked in the NEET examinations. Okay? Let us write them down point by point. First of all, this ionization enthalpy is inversely proportional to atomic radii. What do I mean by this? Suppose I have an atom, let me write it over here. This is an atom, this is the nucleus, this is the electron. This is the distance between the two, r. Second is this case, and the distance over here is, say, capital R. If you apply the formula for electrostatic force of attraction, this is F is equal to K Q1 Q2 by R square, right. So, smaller the distance, more is the force of attraction. So, this electron is closer to the nucleus because the size is small. So, you will require more energy to remove this electron. So, that is why if lesser the atomic radii, more will be the ionization enthalpy. Now, how do you incorporate this point into the periodic properties? Here you will say that on moving from left to right, in the periodic table, or you may simply say or in a group, rather in a period, sorry, in a period, the ionization enthalpy increases. Okay. Same way, you can also say on going down the group, the ionization enthalpy decreases. Why? Why? Because when you are going down the group, the shells are adding and the size is increasing and the electron is farthest away from the nucleus, right. So, ionization energy decreases. Okay. This is the first point. Second one, see, this ionization enthalpy is directly proportional to the stable configuration . What do we mean by this? See, over here I am writing that on moving from left to right in a period, this value is increasing, right. So, what I am trying to say over here, that when I move from carbon to nitrogen to oxygen, the ionization enthalpy should increase. But to our surprise, the ionization enthalpy of nitrogen is greater than the ionization enthalpy of oxygen, right. See, normally we are talking about removing the outermost electron, but still it is better that we mark it also. When I say 1, what do I mean? Removing the first electron from the outermost shell of nitrogen. Similarly, over here, removing the first or outermost electron from the atom of oxygen. Okay. Now, you will ask me, sir, why? Why is this value high? Because this is contradicting this. Okay. So, this is where the stable configuration concept will come into the picture. Nitrogen is having an electronic configuration of 2s2 2p3, whereas oxygen is having an electronic configuration of 2s2 2p4. Now, as per the Hund's rule, the half filled, fully filled orbitals are more stable. So, this is a more stable configuration. Since this is more stable, the energy required to remove an electron from this stable atom is more. That is why, even though oxygen is having a smaller atomic radii, still the ionization enthalpy of nitrogen is more than that of oxygen. Okay? So, this is the first kind of question that they can ask in the NEET exam. Second thing, see, it is very evident from here that larger the atomic radii, lesser the ionization enthalpy. So, if I am writing the ionization enthalpy 1 of sodium is smallest in its respective period, that is the third period, you will agree with me, right? Now, at the same time, if I am writing ionization enthalpy 1 of argon is highest in its respective period, this is again the third group, you will agree with me. Why you will agree with me? You will say, sir, argon, why is it highest? See, first of all, when you are moving from left to right, the atomic radii is decreasing. So, this is having the smallest atomic radii in the third period. At the same time, argon is having a fully filled orbital. The configuration is 3s2 3p6. Its octet is complete, right? So, because of that, its ionization enthalpy is highest, right? Now, these are two facts, but how I can convert these facts into a question? This is very important. Normally, they will not ask a very straight question. They will try to manipulate the concept. It's not very difficult, so don't worry. We'll do it. It's very easy. Just pay attention to what I'm trying to say over here. Now, I'm saying that ionization enthalpy, the second ionization enthalpy of Na is highest in the respective period. I know you must be thinking, why, sir? Why is it highest? Here you are writing it is the smallest, here highest. Why? Okay, don't worry. Let me tell you what is the secret over here. See, this sodium is having an electronic configuration 281. So, it is having one electron in its outermost shell. Now, when it releases the first electron, it becomes Na plus, and it is having configuration 28. And what is this? Noble gas configuration. This is noble gas configuration, right? You will say, sir, now what? See, if any atom or ion is having a noble gas configuration, you require huge amount of energy to remove the electron from there. Okay. So, now if you want to remove one electron from here, that is 2, 8, to make it Na2 plus 2, 7, you will require a huge amount of energy. So, if this is first ionization enthalpy, this is second ionization enthalpy. Dear friends, this second ionization enthalpy is very, very large as compared to the first ionization enthalpy. Okay? Now, I know there is a question in your mind, sir, what do you mean by very large? How do we identify what is very large and what is not very large? So, for that I am giving you a small trick over here. In general, dear friends, please note, I am using very specifically the term in general. Okay? In general, whenever there is such noble gas configuration being formed, the next ionization enthalpy is approximately 5 times of the earlier one. So, in this case, the second ionization enthalpy of sodium is 5 times than the first ionization enthalpy. And dear friends, this thing only is termed as quantum jump. Which means a huge jump. Now, are you guys ready for a question of Ames? Huh? Because everybody dreams to crack Ames. Huh? You say, yes sir, we are ready. Okay, let us pick up a question. I am saying that I have the successive ionization enthalpies of an atom. The first is suppose 100 kilojoule per mole. The second is suppose 190 kilojoule per mole. The third one is 1100 kilojoule per mole. The fourth one is 1400 kilojoule per mole. And the question is, this element belongs to first group, group 2, or rather I can write 1A, 2A, that will make more sense. Third choice, group 3A, or the fourth choice, group 4A. Okay? How will you identify? So, my dear friends, what is it that you have to see? You have to check for the quantum jump. Where are you seeing a quantum jump? Is this a quantum jump? Let us reiterate. Quantum jump means 5 times of the previous ones. Is 190 5 times of 100? You will say no. Is 1100 5 times or more of 190? You will say yes. This is quantum jump. So, what do you mean by this? We mean that after losing 2 electrons, what do we mean? After losing 2 electrons, this atom must have acquired the noble gas configuration after losing 2 electrons. Okay. So, if this is the atom, suppose 1, 2, 3, 4, 5, 6, 7, 8. After losing 2 electrons, it requires the noble gas configuration. It means that in the outermost shell, how many electrons are there? 2. So, if in the outermost shell there are 2 electrons, then this must be belonging to the group 2A. So, this element is basically an alkaline earth metal, right? So, in the exam they can even say like that. Instead of group 1, they may say alkali metal, group 2 alkaline earth metal, group 3 boron family, group 4 carbon family. Okay? So, this is the kind of question that they can ask you in exams like Ames. Okay? See, these exams are not very tough. The only thing is, when you are studying these topics, you need to have an, the bent of mind should be that what kind of questions can be asked from here. These statements appear to be a bit confusing, contradictory, and that is why most of the people fear inorganic chemistry, because they think that there should be a straight line thought process. Yeah, it will be, but when it comes to creating a question, that is where they play the trick, right? So if you are paying attention towards what kind of questions they are asking, believe you me, you will be fond of inorganic chemistry, because you will be able to secure maximum marks in minimum amount of time, and that is the trick to crack the AIIMS exam, right? Hope you guys have enjoyed this session. Keep watching this particular channel for more such videos. Please remember my name. I am Praveen Kumar. Do like this video. God bless you. Bye bye.